Hello YouTubers and welcome to another episode of Cracking Irodov. I am Pranav Singhal from the YouTube channel named Physics Lover, and today I am going to discuss the question number 1.19 of this great book by Sir Irodov. So let's not waste time and crack this question. So the question says, question number 1.19, point traversed half a circle of radius r is equal to 160 centimeter during time interval capital T is equal to 10.0 seconds. Calculate the following quantities averaged over that time. The mean velocity, the modulus of the mean velocity vector, the modulus of the mean vector of total acceleration if the point moved with constant tangential acceleration. So I want to do a correction in this question. The the part of the question A appears to be confusing, ambiguous for me. It says the mean velocity, and the second part also says the mean velocity vector. So I think, in my opinion, this should be speed, not velocity. As second question also says the mean velocity and the first also says the mean velocity, so both the questions can't be same. So I have made a little correction over here, and I think it appears good now. So let us first draw a big circle, a big, it's not appearing like a circle but actually it is a circle, and the center of the circle here, this is one radius, this is also a radius, and the radius was equal to 160 centimeters. This way is also equal to 160 centimeters. So this is our circle in which the point is traveling from this point A to this point B. So our first part of the question says the mean speed, and we know that speed average is equal to total distance upon the total time of that journey. So here our total distance will be equal to the half the circumference of the triangle of the circle, that's equal to pi r, that's simply equal to 160 pi upon the total time, that equal to 10 seconds, and this answer is simply equal to 16 pi centimeters per second. That gives our first answer to this question. The second part says what about the average velocity vector? Now it's the velocity stuff over here, so we will take the displacement from going from A to B, and this displacement is simply equal to 322 centimeters. So our average velocity magnitude will be equal to displacement upon time, and as we know that our displacement is equal to the shortest distance between the first point to the final point, and that's equal to 160 plus 160, which is equal to 320 centimeters upon 10, which simply gives us 332 centimeter per second. Please note that the unit here is centimeter, not meters. I also confuse in these terms. Now let's come to the next part. Now it's a tricky part over here. It's really very tricky part. The modulus of the mean vector of total acceleration if the point move with constant tangential acceleration, and it's the key to the question, the constant tangential acceleration. At all this point, the path has the particle wants to go in like this tangentially, and at this moment it would go somehow like this. So over here it is saying constant tangential acceleration, but how can this be a constant as this direction is always changing over here? Its direction is always changing, the direction of velocity is always changing, and if the velocity direction is changing, it means that there's somehow some form of acceleration over here, and it's constantly changing, the acceleration is constantly changing. So for a circle, in doing things like this, we can take constant only a value 0. So we are assuming in this question that we are taking this value as 0 of the constant acceleration over here, and this particle is moving like this over here. And we also know that our mean mean acceleration is equal to the final velocity minus the initial velocity upon time, and we also take the direction over here. So as we have taken our acceleration, tangential acceleration is equal to 0, we are assuming that it equal to 0. So our mean acceleration will be equal to final velocity minus initial velocity upon time in the x-axis, in this I cap, as this is our initial velocity in this positive x-axis, and this is our final velocity towards the negative x-axis, and let this be equal to v and this be equal to v. So our final velocity was equal to minus v, our initial velocity is equal to v, so it would be simply equal to final was minus v and initial was v, so we'll write minus v over here upon t I cap in the x-axis. Now comes the tricky part of the question. What value of v have to put over here? Do we have to put this speed average, or we have to put the modulus of the vector v over here? So think of this solution of this situation over here. I have used a I cap term here over here that specifies the direction in which the particle is moving at that point, at that time moment. So if I have to put v over here, what will it imply? This implies that it's the magnitude, it's the speed of the velocity over here. So we will simply put over here speed. And please remember this is a very confusing term over here, and many of us do this mistake. Even I, when I first did this question, I put on the velocity modulus, that's 32 centimeter per second over here, but actually we have to put the speed modulus over here, that's equal to 16 pi, and we will get as minus 16 pi upon the whole time moment under I cap, that's minus 32 pi upon 10 I, and that's approximately equal to minus 3.2 into 22.7 in the x-axis, towards the x-axis, and that's approximately equal to minus 10 meter per second square in the y-axis towards the x-axis. And this solves our third part of this question, of this really simple question. I suppose with this third part, really a clever question of this kind, you are gonna confuse for the first time whether to put v as modulus of velocity vector or the speed vector, so not vector, the magnitude of the speed. And this solves a question, and our answer is in, the beautiful answer is in front of us. So I think this will help you all. Please hit the magical button, the magical like button below, and subscribe to my channel if you think this video was good for you and it helped you.